pressure energy. Now, you might have seen the mechanical energies like kinetic energy, energy due to motion, potential energy, energy by virtue of its position. Then, what is pressure energy? Can be defined as the energy possessed by a system by virtue of its pressure. Now, for example, suppose we consider a vessel and at this particular point there is a hole is the and here there is a piston attached. There is a piston attached to it. Okay. Now in this vessel, if I start filling the water, up to this particular point, as I fill it, you can see that the liquid will be getting filled up slowly upwards. But what about the position of the piston cross section? Let's see. As the water is getting filled up, okay, slowly this piston cross section will be pushed away along this direction, and finally let us consider the piston is reaching at this particular point due to the pushing of the water on the piston surface. Okay, so to this distance, delta x distance, the piston is pushed outward due to the pressure of the liquid on this one. Now, if it is pushed to delta x due to the pressure, then liquid will be applying a force on it and there is a work being done by the liquid. Now, if you can calculate that work done by the liquid, then that can be taken as the that can be taken as the energy derived from the pressure. So how to calculate it? To calculate that, what we do is, we push this piston back to its initial point. Means, I will be applying force along this direction and make the piston to come back to its initial position. So for that, if I have applied a force on it, I have applied a force on the piston to make it slowly come back to its original position, or else I will be pushing an amount of water into the beaker by applying a force F. Then I will be doing an amount of work. A small work is done there. That small work, delta W, will be equal to force applied into distance through which the system is moved. As you studied, force into displacement is the word. Displacement along the direction of the force. Yes. Here the displacement is taking place along the direction of the force. Now this amount of work done is, now we can consider it as the pressure energy, because I am doing work onto the system against the pressure of the liquid. Now the force I have to apply there, F will be equal to pressure into area of the piston. If this is A, the area, and pressure on this one, let it be P, then pressure into area gives the force. So this is the force applied by the liquid onto the piston, but I will be applying a force against it almost the same. Then I can push it back into the vessel, the liquid. Then, if I put that over here, the small work done will be equal to pressure into area, the force into delta x. But this particular quantity, area of the piston into delta x, that area of the piston into delta x is nothing but the volume of that shaded portion, or the volume of the liquid I am pushing back into the vessel. Therefore, the delta W will be equal to pressure into small volume of the liquid back into. Then, this can be written as pressure into volume is equal to mass by density. Then, the small work done, I can take it as what you call pressure into mass of the liquid pushed back into divided by its density. Okay? Then, this much amount of work done on the system is getting stored in it as what you call the pressure energy. So, this can be equal to what? Pressure energy. So, for pressure energy, the equation is pressure into mass divided by density. Pressure into mass divided by density. If you want, you can check it using your dimensional analysis. You will be getting the dimension formula same as that of energy. So, for the stored liquid or due to a stored liquid or a fluid, there can be an extra energy coming. It is called pressure energy, and the equation for pressure energy just now we derived. And this pressure energy equation is considered in the case of a theorem called what you call it as Bernoulli's theorem. That is what we are going to see in the next class.